Welcome. How is everyone doing today for the second time? All right, I came all the way from the United States, so I'm going to need a little bit more energy. How's everyone doing today? Bye. There we go. Awesome. So this is Master Tooling for Containers with DevOps. My name is Jessica Deen. I'm a senior cloud advocate with Microsoft. I get asked a lot what that actually means. First and foremost, I'm an engineer, but I get to engage with communities, whether it be developers, engineers, ops. If you touch software, write software, you're, to me, a developer and engineer. So I'm here because I love technology, I love working with other engineers, and I love engaging with the community. My background was I spent 10 years as a systems administrator, then started putting on a little bit of a dev hat, then diving even deeper down the rabbit hole, and now I just do stuff with code and touch computers every day. I'm being told not to walk so far. Got it. All right. Now, I focus very heavily on Linux, open source software, of course, DevOps, and containers, which everything is what we're going to be talking about today. Non-technical facts about me. I always like to throw a little bit of humanity in there. But I love Disney and CrossFit and fitness. So if you follow me online, you'll probably see a picture of code, and then CrossFit, and then something with Disney, and then back over to code. So I like to have a wide range of different things that I feature. Clearly, that wide range is a total of 3. There's no relation to James Dean. Now, I never know how this joke is going to land in whatever country I'm in, but I put it in for the spelling of my last name. My last name has 2 E's. I love connecting with everyone that I meet, everyone that I speak with. If you have questions, want to get clarity on something, please feel free to reach out to me online at jldeen, at Twitter, Instagram, and GitHub. Everything that I ever demo is always going to be available publicly on my GitHub, and there will be a link to everything you'll need at the end. Just a quick disclaimer before we jump right in. We really have about 43.5 minutes since I spent a minute doing an intro. But I want to make sure that we kind of set the playing field for what we're going to be talking about today. This session was specifically designed to get you thinking, to get you excited, and to show you what's possible. At the end, I will give you resources to learn more, but it is going to be very high level, and certain parts of it may feel very fast-paced, but I promise you everything that I'm showing is already available online, and there's even videos and recordings you can pause and recap at your leisure. So now, to get started with the session, I want to talk about the state of our industry, the state of tech, or this digital world that we're currently in. And to do that, I love starting with this particular quote, because we know that technology is changing, which means our jobs are changing, the demands of us are changing. Monty C.M. Metzger wrote, "Uber, the world's largest taxi company, owns no vehicles. Facebook, the world's most popular media owner, creates no content. Alibaba, the most valuable retailer, has no inventory. Airbnb, the world's largest accommodation provider, owns no real estate. Welcome to the digital economy. Welcome to our world as we know it from the engineer, developer, operations, IT pro perspective. How can we keep up with this growth? How can we keep up with this change? What tooling, products, what can we use, or practices, systems can we put in place to help us scale with this kind of growth?" So just by a show of hands, here's some audience interaction for you. How many people would feel comfortable identifying themselves as a developer? Wonderful. And how many people feel comfortable identifying themselves as an operations person? Good, healthy balance. And how many people wear whatever hat their boss tells them to wear that day? Everyone's hands should be going up. I mean, otherwise we need to have a conversation with your boss. But the point is remember, when we're coming from this perspective, whether we're a developer, operations, jack of all trades, we need to figure out how we can implement these practices. So to do that, we have to recognize where each person is, right? We need to hear how that person feels, the perspective, the playing field. So for the developers in the room, this might sound familiar. I need to create applications at a competitive rate without worrying about IT, right? I need to make sure that IT is not the bottleneck to my success. Why can't I just take this zip disk or this floppy disk, USB drive, CD-ROM, whatever it is, and walk over to the server and plug it in? Why do you not let me on your servers, Mr. IT or Mrs. IT person? New applications, this is one of my favorite ones, because I feel like we hear it all the time. The application runs smoothly on my machine. Why doesn't it work on your server? It's your server's problem. So we push it back on the IT person. And then for the developer, again, my productivity and application innovation becomes suspended when I have to wait on IT. Ultimately, developers have felt as though IT can be the bottleneck to their productivity, to their success. So it's hard for somebody in that development mindset to consider scaling with the previous momentum we talked about if the operations or IT person is potentially blocking them. Now, for ops, remember, I spent 10 years as a systems administrator. I'm going to get to you too. We have our own feelings. For one, we still need to manage our servers and maintain compliance with little disruption. You can't just go over to your server and copy whatever file you want onto it so that your application will work. But because I'm not natively a developer, I'm unsure of how to integrate unfamiliar applications in this system. I need to work with you. So I don't want there to be a wall. I don't want bottlenecks, and I don't want barriers. But I'm also unable to focus on server protection and application compliance. I need to worry about the security of my infrastructure, and you need to worry about the security of your code. And to do that, we need to communicate. We need to collaborate. It's the only way we can be effective together. And that's where we kind of start getting into this conversation of why containers is important and why DevOps is important. Because when I put up here IT stress points, I've had developers tell me, well, that's only for IT. That's only for IT Pro. No, if you touch software, if you write software, if you support or write the infrastructure architecture software runs on, this is our collective responsibility, and this is our collective stress points. We all have to worry about security, we all have to worry about efficiency, and we all have to support this innovation and this changing industry. Once we understand where everyone's at, we can start working together to start solving problems and working in a proactive way. And that's the concept of DevOps, is removing this wall of confusion where we just toss this thing over to the other person and hope that it works. This is little Dono dude, by the way. That's my boss, but he is much taller in real life. He came up with this quote, and I love it. He actually labored 30 days over making sure that every single word in this quote is perfect, because it's that important, and it means that much to him and everyone on our team. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word on that slide is value. If you're not delivering value, what are you doing, and why are you doing it? And more importantly, do you know if you're delivering value? How can you gauge it? Do you have tooling in place, telemetry, metrics, insights, something that helps you gauge if you're delivering value? All of this is essential, and that's where we're really going to start our conversation. Because we've all kind of heard DevOps practices. You're going to see that in the demo today. We have infrastructure as code. You might also be familiar with pipeline as code, CI/CD, that's your build and release stages. But the last two are features or practices that don't really get talked about often enough. We hear automation, automate all the things, except you don't really want to automate everything. You want to automate everything you can. Certain things you may not be able to or might not make sense, but so often it has a connotation that you're automating to move forward. Can you automate and fail fast in the event of a failure? Can you automate your recovery? For monitoring, that's how you can tie in availability, performance, telemetry, metrics, and gain insights if you're delivering value to your customers. And then you can take that insights and plan again for your next sprint. And you're going to need your operations and your developers, jacks of all trades, in the same room to play a part in all four scenarios, all four practices. And containers really ties right into everything we're talking about. Because remember the bottlenecks and the obstacles for the developer and the operations person. For the developer, it enables this write once, run anywhere microservice architecture. I no longer have to deal with, it works on my machine, why doesn't it work on yours? Let me just go over and set it up on your server. You don't know how to deal with my code. We remove that, right? Because now we've made something immutable and portable. And that leads in for a benefit for operations. Portability is huge. We also have standardization. Now I don't have to worry about managing dev, test, QA, canary, prod. I know the environments are all in alignment. I'm using something that is repeatable. It's predictable. I have higher abstraction. I have higher compute density, and I can scale. And that's ultimately what we need to do when we're dealing with an industry that's constantly changing. So just to make sure everyone's on the same page, I've done this session probably close to 100 times now, and I still will get asked what a container is. So just to make sure, it is not a real thing. And I love people's brains sometimes. They're like, wait, what? I thought containers is a big thing. It is, but it's really not an actual tangible thing, right? It's process isolation. It's an application delivery mechanism with process isolation. So when you have your container running, it's essentially an encapsulated runtime. It's based on several Linux kernel features. So if you come from a Windows background, you have things like your namespaces. That's what a process can see. That's your mounts, your networks, your C groups. And then your C groups is what a process can use. That's things like your memory and your CPU. And if you're familiar with declarative syntax and Kubernetes or even Helm charts, you might already be familiar with setting resource requests and limits, where you're confining your process and what your process can use to that hardware, to the memory and CPU. Here's another little fun graphic that I do love. It kind of paints the picture on how containerization is different than virtualization, right? We all know virtualization either runs on top of bare metal, or sits, the hypervisor runs on top of bare metal or the operating system, but each virtual machine is different. And the container is that encapsulated runtime that has your base image, it has your libraries, it has the actual application, all in one immutable, portable container. Here's another great image of what that looks like. In the actual image itself, for the image layers can be cacheable, but remember they're read-only. So once I flatten that, that is an immutable object. Your read-write happens at the top, which is the container layer itself. Now, advantages, we've already kind of talked about a ton of advantages for containers, but remember the problems we talked about for the developers or IT. Containers really solves a lot more than just, okay, I can run this anywhere, it's portable, that's great. But it gives me now the ability to iterate fast, which allows me to help scale and meet with this growth. I now have a more agile delivery. We've talked about immutability. And for the IT person, there's cost savings involved, just even from a time perspective. I'm not having to run around to all these different virtual machines and servers and try to figure out if this version of Java is the same on dev as it is over here on QA, and who updated this and who did that. There's cost savings, which leads into an efficient deployment. And containers even gives me things like elastic bursting, where I can go from the public cloud over into the private cloud and vice versa. So there's a lot of flexibility. So as much fun as PowerPoint is, and I'm sure listening to me sit here and do hand gestures and point at, ooh, look at this slide. Now it's demo time. Now we're going to have some fun. So if you were already familiar with who I am before, you've probably seen me post pictures of this ad nauseum at this point online. It's a game I've taken around the world called Croc Hunter, where you can live out your days hunting crocodiles on a boat. And you get to roll around and, oh, look at that, I scored 5 points. It's a silly little game, but the point of it, and the reason how come I love this container, is when we scroll down here, you can actually see the host name. Now, if I refresh the browser, you'll see that host name keeps changing. The ending prefix keeps switching. It's because I have 3 different replicas. This is a JavaScript application wrapped in a Go web server running on a Kubernetes cluster in Azure. It was deployed out using a Helm chart. I have a CI/CD system that's handling my deployments. There's image scanning happening. Helm charts are going to a private repository. Docker images are going to a private repository. I can see the release name, the commit ID, and as I said, I am using Helm charts to do the deployment itself. If I refresh this particular page for my GitHub repo, you can see the latest commit. We'll zoom in right here, is 086661. We'll zoom right out, and that was the commit ID here. So when you have an actual pipeline in place, which I have, and I have actually in a pipeline as code, so we'll go back over here, and I'll show you the pipeline I'm using. To demo this, I'm going to be using a CI/CD tool called CodeFresh, which I love because it helps you visualize what's running in your Kubernetes cluster. You can see your Helm deployments. You can see it visually without having to actually run manual command line commands. So I have different stages. I'm building, we'll make this a little bit bigger here. I'm building a Docker image, I'm pushing that image, I'm packaging the Helm chart, I'm setting environment variables, I'm setting environment variables per dev environments and production environments, and then I'm also building a test image. I run Selenium tests with this. I make sure that everything tests right in Mozilla and Chrome. And then I move on further, and I ultimately end up publishing these results. I have JFrog Artifactory is my Docker image repository and Helm chart repository, and then Xray is scanning the images so I can make sure I'm within compliance. So as much fun as Croc Hunter was using a fish to shoot crocodiles, I'm going to make a change live and see if I can have a little bit more fun here. Again, like I said, it is technically a JavaScript application wrapped in Go. So here's my Go file here. I'm just going to change this to, I made a special little project for you called Devoxx. So we'll go ahead and save that. I'm going to check this in and say Devoxx. Now, once I commit this and push, because I have my DevOps practices in place, because I have a pipeline in place, this is going to automatically fire off a build and release. I have the hook already listening on my GitHub repo. If I go over to CodeFresh, which, as you can see, I can navigate around. I have build and test and deploy, DevOps Insights. If I go into my Kubernetes cluster right here, you can actually see all the different Kubernetes namespaces I have, how many services I have running in each. So this particular deployment lives in a namespace called OzCon. So you can go here. You can see I have different services running right now. I can even see the image ID as well as the old commit ID. Now, if I zoom out of this, I can also go down to Helm. I can see my Helm releases as well in a very visual instance. You can see anything I have, including Jenkins. I do have a few other Croc Hunters. That might be a little spoiler alert. But I can see the last revision, when it was done. When I go over into repositories, I can see what's actually happening. I can go to builds. I can see that my build pipeline is in progress. It's pushing the Docker image right now. And once this completes, we'll be able to refresh and see a new game. But the cool thing is like I said, I do have Xray tying in. So Xray, JFrog's Xray, which is a binary investigation scanning tool, is double checking that I don't have any violations. So there's a bunch of practices that are put in place to make sure I'm set up with scale that I'm delivering value. It wouldn't be very valuable to my customers or to my end users if I'm pushing something out that ultimately is full of security loopholes or, God forbid, stores your password in plain text, which several plugins in Jenkins does. But I still have a Jenkins build server as well. I'm not saying that's a problem. I'm just saying be mindful of your images, be mindful of your code. Security is important, so we want to have tools in place that's scanning that. I can even scan, you can see right here, if I zoom in and make this a little bit bigger, I have a tarball file. That's my Helm chart. I have a bunch of manifest files. All of these are scanned, and no issues were reported. Now, if you want to see what issues reported actually looks like, let's just search for Debian. Oh, and now we have some high issues, and I get nice red letters that tells me, okay, you have some problems in these particular components. You need to take a look at that. I can go over to my artifact repository. I can go to Docker right here. It might make me sign in. And I can actually see my deployments as well. I can see under OzCon. This is a demo I've just reused. I can see all my different branches. I can drill down into everything and have my Docker info readily available. Gives me a lot of control. I can even go over to package views and search for Croc Hunter and see that I have various Croc Hunter Alpine images. Having things that are all in the same place that link back over to either Xray, Artifactory, or scanning, whether you're using Quay or any kind of private registry, you want to be able to have that insight that you're within security, that you're within compliance. I can see that this deployed successfully. Before I showed you before I show you what I actually deployed and what special treat I created for you, I want to show you the images because I pushed everything right into artifacts. Again, locality matters, so I can go right in. I can see the commit was for Devoxx. The CodeFresh quality is confirmed. I can drill down into my summary page, and I even get a nice little report with the Xray reports confirmed, with the build reports confirmed, with the messages confirming. It shows up a little weird when I tend to zoom in on my browser, but you can see it was scanned by Xray, and it passed with no alerts. So I have everything tidied up nice and neat within my CI/CD pipeline. Now let's go back over, and I'm going to refresh Croc Hunter here real quick. And I have a Devoxx France edition. And since I work for Microsoft, we're going to partner, and now we're going to use some Azure to play this game. Now, the beauty of this is you saw that I had quite a few different Kubernetes services and Helm charts deployments. I'm not trying to just showcase one CI/CD tool. I'm trying to showcase the value of making sure you're scanning your images, using Helm charts, setting things up that help streamline, that work very simple. All I had to do was make my code change, push it, and my CI/CD system took care of the rest because it was set up and configured properly. But if I go over to my GitHub here real quick, and we'll go back to the root repo. I have to zoom out because it's so big even I can't see. You'll see that it passed because I have the little check mark. But if I drill down into it, I actually have two other tools that did the same deployment, just to different endpoints. Because I use a Helm chart, I can override wherever that's releasing. I can make sure that I'm maximizing my value. I can have different environments, different systems in place. I get asked a lot, what tool should I use for CI/CD? What tool should I use for image scanning? What tooling should I use for my artifact repository? Use what works for you. There's not necessarily a one-size-fits-all, but there's a lot of different tooling that is capable of supporting this. So I showed you CodeFresh, and I showed you Xray, but I also had Azure DevOps running that same exact pipeline. You can see right here it had one new build, Devoxx. We'll zoom out here real quick. It was just run. And if I refresh, this is says ADO Croc Hunter, stands for Azure DevOps. We'll zoom out and refresh here. It also has the same exact addition. If I go over and refresh this to make sure I'm signed into Jenkins, I also had Jenkins running it as well. And you could see right up there, Devoxx just passed. By the way, my Devoxx server crashed literally 20 minutes before I was on stage here, which is probably why I was walking in a little late. And I was able to get it redeployed, up and running, pipeline and everything restored, because I have everything saved in a Helm chart and in source control. And I have these practices in place to where in the event of a failure, I can fail fast and recover. And that's the value of making sure you're using container tooling that makes it simple. So I'm going to switch back over to PowerPoint here real quick. I know PowerPoint is everyone's favorite, but I have just a few more slides I want to go through, and then I'm going to show you how to simplify this even further. So what did we see? We have code on GitHub, and we had a Kubernetes pipeline. The primary pipeline was CodeFresh that I showed you, and I have I have Selenium reports tied into that, though I didn't show you that. It's a little bit harder in a shorter time frame. But I have Selenium, we saw Docker scanning. There's a bunch of stuff in CodeFresh. But we also know that we had stuff in Azure DevOps and stuff in Jenkins, and it essentially did the same thing. Every single CI/CD system handled Docker, packaged up my Helm chart, deployed over to Kubernetes on Azure. CodeFresh obviously did my Selenium scanning and my Xray scanning. And then for my Kubernetes registry, I was using JFrog Artifactory and Xray for the CodeFresh demo. For the Jenkins demo, I'm using Azure Container Registry. For the Azure DevOps registry, for the Azure DevOps demo, I'm using a different Azure Container Registry in a different subscription. I can completely separate out where I want to put whatever, but the pipeline remains the same. The fundamentals remain the same. So for anyone who feels like this is a little over their head and is still not quite sure what Kubernetes is, it's an open source container orchestrator. It was originally designed by Google based on a system that they use to run billions of containers per week. The system was called Borg. It was designed intently to automate deployment, scaling, and management of applications. It includes built-in features like automatic bin packing, service discovery, load balancing, secret management. I'm deploying out to 3 different private container registries in that demo. I have to store the secrets somewhere. With Azure, I can link over through service principals, but using Kubernetes, I can also store image pull secrets securely, and I make sure that they're encrypted. Not only does it support the ability to roll forward, we can roll back. So we talked about DevOps practices. One of the reasons why I believe Kubernetes is so awesome is because it's built on DevOps practices, that the industry is finally starting to understand we need to embrace this. To keep up with this momentum, this is crucial and essential. Key terms, as you start going down the Kubernetes rabbit hole, you'll see things like replica set, stateful set, daemon set. You have your services, your ingresses, your namespaces. Each deployment deployed out to a different namespace. And on all of my clusters, I use an ingress. I use an Nginx ingress and actually even have Let's Encrypt set up on there. So TLS was automatically provisioned on all 3 different endpoints by my Kubernetes cluster. I didn't have to do any kind of TLS termination. And there is a 16-minute video on YouTube that'll be available and a link at the end to learn a little bit more about that. Now, we also have a reconciliation loop in Kubernetes. So for those that are still trying to understand how Kubernetes works, you essentially declare the state of the world or the state of your applications that you want it to be, and Kubernetes reconciliation loop will check its actual state and constantly try to reconcile that. Make sure that the actual state is in alignment with your declarative syntax, with what you've defined. And if you haven't seen a deployment YAML or service YAML or any kind of YAML, this is what that looks like. This is deploying out a deployment object, and you start defining your declarative syntax, which you want. This is for Nginx. You set your metadata. You set your spec with your replicas. Croc Hunter is running 3 replicas, so there would be a pod on each individual node. This demo is 2, so it puts it just at 2 nodes. In the event one fails, the application's still available, which also made it really simple for when I did that update, when I made my change, there was never any downtime because it kills one pod, makes sure that it starts up the new one, that new one's healthy, kills the second one, gets a second version of the new pod healthy, leaves still one of the old one. Once both of these are healthy, then it kills the final one, and I finally have 3. So it does a rolling update. And then under spec, I can define my containers. In between spec and containers, I can shim information in for image pull secrets. I can define what I want, and the Kubernetes scheduler and etcd will make sure that it happens. In the demo, I did use Kubernetes on Azure. It's AKS, which means it's your Kubernetes cluster. It's just managed by Azure. It's still 100% upstream Kubernetes. It's not a Microsoft version or a Microsoft fork. It is still 100% open, upstream, open APIs. Now, you might be wondering why AKS. First off, it's the fastest path to Kubernetes on Azure. You could run, if you wanted a Docker run version of Kubernetes, that would be Azure Container Instances, but you have no control over the agents or essentially anything, really, right? You're just kind of doing Docker run in the cloud, and the back end is Kubernetes. You can get up and running with 3 simple commands. I like to argue it's technically 2.5, and you'll see why. And like I said, it is 100% upstream. Now, it's also easy to manage. So it has automated upgrades and patching. I can very easily scale the cluster up and down. I can even do horizontal scaling. It has a self-healing control plane. We back everything with a 99.7 SLA. And to get started, this is why I like to argue it's 2.5 commands. This is using Azure Command Line, which is cross-platform, works on Linux, Windows, and Mac. But the first command will create your cluster. The second command is that half command. If you already have, and everyone always gets mad at this, it's either kubectl or kubectl. I know there's a Reddit debate. Whatever you want to call the binary. If you already have that installed, you don't have to run the second command, because that's all the second command does. The third actually sets up your credentials to authenticate your local system over with your cluster. And then the fourth is really just to show you're interacting. Now, for managing AKS, I kind of do the same thing. It's very native. AZ for Azure Command Line. I'm working with AKS. I want to list my objects. I want to upgrade my cluster. I want to scale my cluster. And I can do that very simply. Now, regardless of which cloud you're using, if you're using an unmanaged version of Kubernetes, first, why? It sounds very painful. I've been there. But 2, this is a visualization of what that looks like. You're responsible for the master VMs, the canonical updates. You have to drain, cordon. You have to deal with everything when it comes down to upgrade time, patching, including your agent pool. But when you have a managed service, whether it be Google, Amazon, Microsoft, Oracle, Mesosphere, it doesn't matter. You're going to have a hosted control plane, which takes care of the etcd, the scheduler, everything from the brain. And then really you only have to worry about your agents themselves and your agent pool. Now, we've talked a lot about Helm, and a lot of people, especially if you're not new to Kubernetes, you've already heard of Helm and you've probably dabbled with it. Helm is the Kubernetes package manager. It was originally designed at a hackathon, actually, to simplify Kubernetes itself, and it has since become the de facto package manager, started by a company called Deus, and it's powered by a template engine. So you essentially use variables and parameters to define out what you want rather than hard coding your declarative syntax. Kubernetes is hard, it's complex. The team wanted to simplify. But not many people have heard of draft, because for those that have used Helm charts, how many have had a lot of fun writing Helm charts all on their own? Really? No hands? OK, one person, two people. I have written my own Helm charts as well. However, once I started playing with draft, it streamlined the learning curve that much further. It simplifies your Helm development. It streamlines your Kubernetes development. So we're first going to talk about Helm. As we mentioned, it does manage complexity. You can do very easy updates, and you can do easy sharing. So even you saw in Croc Hunter, I packaged up my Helm chart as a tarball. I can put that up in a private Helm repository. I can pass it off and publish it as an artifact for my release stage. It makes it very portable and tangible. I can also use Helm to do rollbacks. So I had already done the Devoxx release. I could have just run Helm rollback and whatever that release marker was and rolled back to it. Of course, it was more fun to do everything live, but Helm rollback allows me to also automate my recovery. Now, here's another visualization. I can define everything in my values file. I can specify things for databases, whether that be databases on Kubernetes, PVCs, or even external databases or external storage. I can define my services, anything custom for my CRDs. My continuous integration gets tied into that, especially when you think about your networking, your load balancers. You package everything up, and that becomes your application package. And you can version control it right alongside your source code. Now, draft simplifies that even further by essentially allowing you to create a Helm chart and a Docker file and everything you need to deploy out into Kubernetes with just 2 commands. And it's not magic, though I think the team pretty much made it magical. I have no idea. I do know how it works, but at the same time, it's quite brilliant. I use 2 commands, draft create and draft up. Draft create will create my charts based on best practices. It'll create my Docker file, and then draft up will take care of Docker build, Docker push, and Helm upgrade install, and we'll actually release it out into a Kubernetes cluster. You can release it out cloud-wise, or you can use it as a development tool and release it out locally. So I can test everything locally before I check the charts, Docker file, application code into source control, work with my operations person, and get it out into Kubernetes. I can make sure I'm going through all my checks on my local dev machine. It does that using what's called draft packs. So it supports Java, Python, Go, Ruby. I think there's about 10 different languages, and it's an open source project. It was also started by the Deis team. So I'm going to show you a quick demo of that now. We're going to flip back over. This time I'm going to flip over to my terminal. And another question I get asked a lot is, what terminal are you using? Don't worry, all my dot files are also published online in a link at the end. The short answer of that is it's a terminal that I kind of made with a collection of just about 17 different tools. So it's a little harder to answer. But one of the reasons how come I like it is on the right-hand side, you'll notice that it says something Docker for desktop /default. That's because I'm using Kubernetes within Docker on my desktop. This is quite large, so let me switch back over here. Nope, that's still too large. I'm trying to find it to where I can show you my Docker client. And I might not be able to because of the screen size. Oh, no, here we go. There we go. OK, preferences. So if you're running Docker on your desktop, there's a tab when you go to preferences that says Kubernetes, and you can hit enable Kubernetes. In my personal opinion and experience, it's 10 times easier to set up across multiple platforms than Minikube currently is or ever has been. I don't have to deal with virtual machines or anything like that. So that's how I'm running Kubernetes. You can actually still run. It's just like normal Kubernetes. kubectl get pods. I can do services. You can see I have the standard Kubernetes service. I can do Helm LS. I don't have any Helm deployments. Now, I'm going to open. I'm in a directory right now that's an example Java application. You can see that I have my standard POM file, and then I have stuff in a source file. It's very simple hello world. I'm going to close this down. So you can see hello world, hello, I'm Java. Nothing fancy about it. Now, I'm going to go ahead and do those 2 commands I told you about, draft create. And that detected Java, and it says now I'm ready to sail. What that means, if I go ahead and make this bigger, and we'll zoom out just so you could see the left-hand side, I now have additional files. For one, I have a Docker file, and we'll zoom in so you can see, that actually sets me up for success. It's set up lines 1 through 4 is one stage, and then 6 through 12 is a second stage. So it is multi-stage Docker builds. And it also gives me a charts directory. And the charts directory gives me templates, and I have deployment templates that help me get started with my application code. Now I know Hello World can be boring. I also have a video online where I forked a random project I found on GitHub. I threw a dart, searched GitHub, found a Java Spring Boot application. I'm like, will this actually work with a real live application and not just Hello World? Short answer is yes, and you can do it in less than 30 minutes. There's a YouTube video for that. You have to make some changes. You might have to update your port, your internal port that your application serves on. You might have to update ingress information if you're going to ultimately push it out to the cloud. Maybe security permissions or the scripts that's running, or base image version, depending on your tests that you're running. But other than that, with a few minor modifications, Draft works just fine. It's designed to give you the scaffolding to get started. So now all I have to do is do draft up. And this is going to build my Docker image and release it into my local Kubernetes cluster. Now, I did run this command before, hoping that this building Docker image would speed up just a little bit. Oftentimes, doing all the Java, Maven, compiling, pulling can take a little bit of time. But we'll let this run. And once this runs, it releases it. And now I have a local deployment of everything. My Docker file has been built. My Helm chart's been deployed. I don't have to worry about trying to do everything manually or essentially using the cloud as my testing sandbox. So you can see that deployed. I could even do draft logs and see the results of anything that happened. But instead, I really want to run my application. Now, we know that I could probably do kubectl, port forward, connect over to the deployment, because I'm going to switch this to a different screen here. We'll go ahead and do kubectl, get services again. You'll now see I have another service called example Java that's been running for 22 seconds. And I can do the same thing with pods, and that has also been running for about 30 seconds. And if I do Helm ls, we know that I have the Helm chart deployed. So I could do standard connections to port forward. But up at the top screen, I already ran draft connect. Draft will automatically create a port forward over to a proxy address. So now if I curl, I can curl the local host address with the prefix, and I get my hello world, I'm Java. So not only can I run my testing locally as a developer on my system, I can also test to make sure that it's cloud ready, container ready, Kubernetes ready. Now, sometimes this can get very overwhelming, so the last thing I want to show you is something we called Azure DevOps Projects. So if you're wondering how to get started, you don't even have a Kubernetes cluster, you're curious about playing with this on the cloud, you're curious about maybe setting up your own CI/CD server, whether that's Travis CI, Jenkins. You can deploy out a lot, by the way, just from Helm charts that are prepackaged. Those Helm charts can be found on hub.cube ops. You can see there's quite a few. You can even do Anchor for image scanning. You can just search right here, Jenkins. And this stable Jenkins is the same. That did not go there. But this stable Jenkins right here is the same exact chart I used now 35 minutes ago when my Jenkins server crashed. And you're essentially doing Docker and Docker. So if you want to get started and you're trying to figure out where you go, that's where the DevOps Project was created. You essentially go, we'll search right here, you go up to the plus sign, and you just scroll down and find DevOps Project. And that takes you to this page where you can choose your application. We'll zoom out here so you can see a little bit more. We have .NET, we have Node, PHP, Python, Ruby, Go. We even have bring your own code, or even a new IoT app using C. So I'm going to go ahead and choose .NET, just coming from the Microsoft world, though also with Linux. So I'm going to do ASP.NET Core. It's really hard when it's so big. But I'm going to do ASP.NET Core right here. That's where you choose your framework. Now the next is, what service do you want to deploy to? Maybe you don't want to do Kubernetes. Maybe you want to do a web app. Maybe you want to do Service Fabric or Functions app. Or my personal favorite, you want to go back to 2000 and deploy just to a regular virtual machine. So if you do want to learn today's stuff, you want to choose Kubernetes, you simply select Kubernetes, and you fill in basic details. Project name, If you don't have an Azure DevOps account, you can create one if you wanted to get started with Azure DevOps, or you set up your Kubernetes cluster, which this will do for you, and then you deploy out Jenkins or whichever CI/CD system you want. You choose a subscription. There's a link that I'm going to give you at the end that's going to give you credits to get started. And then you create or use an existing cluster. From there, you just hit done. And once that completes, you get a landing page where it literally sets up everything for you, your complete CI/CD system, your even down to your endpoint for your application. So if I zoom in here, we'll zoom in up here, you'll notice this endpoint has a really long prefix. That's using HTTP routing zones, which is Microsoft's version of Nginx proxy. I'm still very stuck on Nginx, so I don't like 0FFBF. I'm never going to remember that. But the point is, it sets you up. It helps you get started. It sets up the services that you need on your cluster. It sets up a pipeline. When you click over into, or when you drill down into your CI pipeline, it has tasks that make sense for your Kubernetes deployment, especially if you're just wondering, what tasks do I need for Helm? By the way, Azure DevOps gives you, it's completely free now for public projects. So we give you 10 parallel builds for public projects and unlimited build minutes. And on the left here is just a task runner. We already pre-populate the build tasks, push tasks, Helm tasks. We give you build agents. You can run Linux, Windows, and Mac builds, all within the same build pipeline. You just specify them by job. This is agent job 1. You could add agent job 2. You can name it out. But we give you the stuff to get started. Once you click done from that, it builds everything that you could possibly think of. And my personal favorite of everything else that it does for you is it also ties application insights right over into your Helm charts. So we talked about value, engaging if you're delivering value. I often get asked, how do I have any kind of insight into what's running in my cluster or my pod? We do have health monitoring. You can use Prometheus and Grafana and other projects to map that out. But Azure, application insights, especially if you're already familiar with app insights and web apps, can be linked directly over into your cluster. All you need is your instrument key, and you just add that into your Helm chart. And starting with tools like Draft, where you kind of get comfortable with editing your Helm chart template, will also help you. You can look at the best practices for how they did it in Application Insight, because we give you all the code on a repository as well. You can drill down into the code. You can see the chart sample app. I can go down into values, and if I scroll down without going back, I can see the application insights instrumentation key is right down here on line 56, and then I can go find where that's referenced in my template in deployment, and I can mimic that in my own charts. So I can use it as a launchpad to learn and to get started. Now I'm going to switch back over to PowerPoint here again. We're going to start from this slide. I always click the other button, and then I have to scroll through. I just want to finish up with some best practices. We did talk about how Draft will create templates and Docker files for you built on best practices. One of the things you saw that it did was multi-stage builds. Multi-stage builds is a best practice for security, efficiency, performance. It's pretty much just one of the best ways to go around it. I actually made a tweet, I think about a month ago, where I took a project I've been using personally for years, Home Assistant, which the Docker image for that is 2.2 gigs, and I was able to get it down into 121 megabytes simply by using multi-stage builds and taking advantage of best practices. Consider your application architecture. Use namespaces. I had 3 different deployments. I can organize the objects in different namespaces. Helm charts is a best practice, which is why it's de facto. Role-based access control, making sure Kubernetes is enabled with RBAC, but making sure that you're locking down your service accounts and not giving godlike permissions to just anyone. Implement health checks. Make sure that your container is alive, is healthy, and if it's not, have Kubernetes restart it. Set resource requests and limits. We didn't talk too much about that, but that is set up in the draft templates that you're given. And then finally, be mindful of your services. Map external services. If you have external databases, external storage, you still can store that link with your cluster. And then don't rely on load balancers. I'm a huge fan of Nginx proxies. It allows me to scale out my one IP and is a lot easier to manage. Finally, all the resources I have talked about can be found at aka.ms/JLDeen/crockhunter. And thank you very much. Now we are at time, so out of respect for the next speaker, I'm going to go ahead and pack up. And if you have questions or want to talk with me, I'll be outside the room. I might swing by the Microsoft booth in a little bit, but I'd love to chat with you. Just meet me out there, and we'll leave the space open for the speaker. Thank you very much.